All right, so we'll continue to look at parabolas this week. We'll just start off with kind of a quick review. So over here, last week we were looking at the factored form. So remember that the factored form was just a way of writing out the equation for the parabola. And it was always written out so that you had two different brackets, and those two brackets were multiplying together. And that's what gave you the x squared, right? The x times x gave you the x squared. It gave you that U-shaped graph. We're going to use this factored form again today, a little bit later on. So just as a reminder, the nice thing about the factored form is that the numbers that showed up in the brackets were the x-intercepts. They told you where the parabola hit the x-axis. And you just had to swap the signs, right? So in this case, this parabola hits the x-axis at 2 and at -4. Right? So we'd say the x-intercepts are 2 and -4. We also use terms like zeros or roots. Those mean the same thing as the x-intercepts. And last week we could start to sketch these graphs out. So we'd say, okay, I know that this particular parabola hits at 2 and -4, and it's positive out front. It looks something like that, and I could get a rough sketch of it. Right? I would need a little bit more information to figure out how far down it goes, but that's our general idea there. It looks something like that. Today we're looking at kind of another key part of the equations. And we're going to use it mostly with the factored form today, but this actually works with any of the forms. You could use it with standard form too. And it's related to the number out front here. So far we've only looked at the sign and we've said, okay, in this case it's like a +1 out front because there's nothing there. That's what makes it open up. That number also represents how quickly it grows. Is it a skinny parabola that's very thin that grows quickly, or is it a wide parabola that kind of grows slowly? And we call that the step pattern. So the step pattern is related to this front number out front here. All right, so let's go through the first one here as an example. So first one, I just have my very basic y equals x squared. That's my basic parabola. So I went through and I started by filling in the table of values like we did on our very first lesson. I went through and said, okay, -3, plug that into my equation, right? -3 squared is 9. So I filled that in. Plug in -2 next. -2 squared is 4. So I went through and I filled in my table of values and I graphed out my basic parabola, right? -3, 9, -2, 4. So I've got my basic parabola there. Now, what we're going to do is we're going to start from the vertex and we're going to look at how the y values change each time we step over. And that's called the step pattern. Each time you step to the right, how much did your y value change? It's kind of like a slope. It's just that parabolas are curved, so the slope is going to change every time you step over. So in this case, starting from my vertex, I stepped over and I said, okay, I go over and I go up by 1. Next time I go over, I went up by 3. And the next time I went over, I went up by 5. So this here is my basic step pattern, 1, 3, and 5. So as long as you have a basic parabola with an a value that's 1, right, there's nothing out front there, it's like a 1x squared, then our step pattern will be 1, 3, 5. Every time you go over from the vertex, you will go up 1, then over and up 3, then over and up 5. Okay. What I'll get you to do is we're going to go through kind of a couple of different equations that are only slightly changed. We're just going to change that a value. And I'll get you to kind of go through, fill in the table of values, try and figure out the step pattern, and then we'll look at how that step pattern is affecting the graph. So at this point, see if you can try the next table out, see if you can graph it out, and then figure out what the step pattern is. So I'll give you a minute to do that. You can pause the video. All right, here's our next one. All right, so once again, I plugged in -3, right? -3 squared is 9 times 2. So I plugged in each one of the x values, filled in my table of values, and this is what my graph came out to. Now we're going to look at that step pattern. All right, so once again, starting from the vertex, I went over 1. This time to get back to the parabola, I went up 2. Then I went over And it looks like I'm going to have to go all the way up 6 to get there. And I could keep going if I need to. Let's see. Over, and I think I have to go up 10 this time to get all the way back to the parabola. Okay. So here my step pattern is now, let's say, each time I went over, it went up 2, and then it went up 6, and then it went up 10. Okay, so that's our step pattern for this one. 2, 6, 10. All right, so in this case, our base parabola, 1, 3, 5. This one is 2, 6, 10. And if we look at the a value, the number that's out front there, the only difference in this equation is that we have a 2 multiplying out front. We say the a value is a 2. And what that's done is it's doubled my step pattern. Right? So my basic step pattern, 1, 3, 5, because of that 2, it's been doubled. And the step pattern here is 2, 6, 10. What has that done? It's made my parabola grow twice as fast, right? You'll notice this one is quite a bit skinnier than the last one because it's going up much faster. It's increasing twice as fast, right? So in the future, when you get to these, you can actually figure out the step pattern without the graph. You can just use the equation. So for example, if I didn't have the graph here and I just had the equation, I would say, oh, I know my parabola starts as 1, 3, 5, but my a value is 2. So I know the step pattern for this graph is going to be doubled. So I'm going to multiply everything by 2. I know my step pattern is going to be 2, 6, 10. So what's my step pattern here? If I can get rid of that, it's going to be 2, 6, 10. And now if I have a vertex to start from, I can actually just plot in the other points. Over, up 2, over, up 6. All right, so once again, I'll give you a minute to pause and maybe try out the next one, and then come back and check your answers. All right, we'll see what we got here. Once again, I plugged in each x value and figured out my y value in the table of values. It's a little bit tedious, but I was able to go through and plot out the points, and there's my parabola. Okay, let's see what we got for our step pattern here. Remember that it's always stepping over by 1 and then up by however much. So in this case, I've now stepped over 1, and this time I'm only going up, it looks like a half. And then from there, I'm stepping over and I'm going up, looks like 1.5. Now I'm stepping over 1 and I'm going up, looks like about 2.5. All right, so this one's a little messy because it's got some fractions in there, but it looks like we went over, over 1 up 0.5, over 1 up 1.5, over 1 up 2.5. Okay, so that is our step pattern. 0.5, 1.5, 2.5. Okay, and in this case, it seems like, I mean, that step pattern is less, so this parabola is a bit wider, right? It's growing slower. Once again, if we only had the equation instead of the graph, we could have actually gotten the step pattern from this as well. We just would have started with our basic step pattern, 1, 3, 5, and then we would have said, oh, my a value here is 0.5. It's a half, 0.5. So if I just multiply my step pattern by 0.5, I have it. Okay, 0.5, 1 times 0.5, 0.5, 3 times 0.5, 1.5, 5 times 0.5, 2.5. Okay, that's my step pattern for this one. Okay, so you can just get it from the equation by taking your basic step pattern, 1, 3, 5, and multiplying by the a value, 0.5 here. All right, so once again, I'll let you guys maybe try out the next two and then come back and check your answers. All right, here's our next one. Okay, the equation's a bit messier here, but once again, I plugged in each x value, worked it out, graphed out the points, and I ended up with a parabola that looks like this. All right, so let's check what our step pattern is here. Now you can maybe guess before you even get there, right? Look at that a value. Maybe you can guess what the step pattern is. From my vertex, over 1, and down 2. Then we went over 1, and down 6. And then we went over 1, and down, looks like it goes all the way to here, down 10. Okay. So in this case, it looks like we went, I'll use negative to indicate we went down 2, and then we went down 6, and then we went down 10. Okay, so that's my step pattern. -2, -6, -10. Right, once again, from my vertex, when I stepped over to the right by 1, I went down 2, then down 6, then down 10. -2, -6, -10. Now in this case, I mean, there's other things added into this equation, but once again, the only thing that matters is that a value. That a value tells you what the step pattern is. It tells you how quickly this graph grows and the direction. Could I have figured it out without using the graph? Yep. I would have started with my basic step pattern. That's for my basic parabola, 1, 3, 5. And in this case, I would multiply every number by -2, because that's my a value. So what did my step pattern end up being? Well, 1 times -2, -2, 6, -6, 3 times -2, 5 times -2, -10. -10. Okay, so you can get the step pattern just by starting with your basic one and multiplying by the a value. Okay, so in this case, step pattern -2, -6, -10. Yep, it matches up with the graph. Okay, last ones. Can we use this for anything? Let's kind of go the other way around now. This time you're given the graph, but you need to figure out what the equation is. All right, let's see what we can do here. Well, I can start by picking out some main points here. So I immediately noticed that the x-intercepts show up. There's an x-intercept at -2 and at +2. So I'm going to start making my equation in that factored form because I know what my x-intercepts are. Right, x-intercepts 2 and -2. And I know that that matches up with the numbers in the bracket, right? Just swap the signs. Okay, so that mostly gives me the equation. The only thing I'm missing is there an a value? Is there a number multiplying out front? And now I can figure that out from my step pattern. So I go to my vertex and I say, okay, I went over 1, and I went down 3, and then I went over 1, and I went down 9. And you know what? It's really only that first jump that matters. -3, -9. Oh, okay, so that tells me, you know what? I know what my step pattern is. It was just multiplied by -3. So -3, -9, -15, right? Because I just took my basic parabola, or my basic step pattern, 1, 3, 5, and multiplied it by -3, the first step. So when you're using this method, you really only care about that first step, right? Because that's going to give you the a value right there, -3. All right, so now I have an equation. Y equals -3 for my a value, x minus 2 from one x-intercept, x plus 2 from the other. All right, let's look at the last one here. Once again, I noticed that the x-intercepts are nice and clear there, so let's start with those. X-intercepts of 1 and 5. That gives me most of my equation. I know it involves an x minus 1 times x minus 5. Only thing I'm missing is the a value, right? Okay, let's see here. Over 1, up 0.5 it looks like. Over 1, up 1.5. Okay. Yeah, so it looks like it went up 0.5 and then it went up 1.5. Okay, and I mean, I really only need that first value, right? So in this case, step pattern looks like it was multiplied by 0.5, right? The a value is 0.5 or a half. So there's my equation. The a value is 0.5 or 1/2. There we go. 1/2 x minus 1, x minus 5. All right, now let's say that you weren't quite sure about the points. Let's say it wasn't quite obvious what the step pattern is. There would be one other option for finding the a value out. And I think there's maybe 1 or 2 questions on the practice for today that does that. It's just kind of an extra way of figuring it out. So your other option is, let's say you were looking at this graph and you said, I'm not quite sure if this goes up by 0.5. Maybe it's like 0.4, or maybe it's 0.6. Is there an algebraic way I could solve this instead? Yes. So instead what you'd say is you say, okay, I know my x-intercepts. Those are nice and clear. So my equation, it's going to look something like x minus 1 times x minus 5, and then there might be some a value multiplying out front, and I just don't quite know what that a value is. So then what I'm going to do is take some other point that's nice on my graph. Okay, usually the y-intercept is nice, but not here. Here I might just take my vertex. That's a nice point, 3 and negative 2. So I could just take my vertex, and I'm going to substitute that point into the equation. It can be any other nice point, 3 and negative 2. So you substitute that into your equation. X is 3, y is negative 2, and you can use that to figure out the a value. Okay, so I replace y with negative 2. I replace x with 3. And now I can solve that for the a value. All right, brackets first. 3 minus 1 is 2. 3 minus 5 is negative 2. Gives me a times negative 4. Divide by negative 4. Negative 2 over negative 4. That's just 1/2. Okay, my a value is 1/2. And that's all I need for my equation. Okay, I rewrite my equation, but I put a as 1/2. And yep, it definitely matches up, right? We were able to get it from the graph here, but sometimes if your graph is not clear, or maybe you're just given the x-intercepts and another point, you're not given the graph. So in that case, you can still find it out. You could just plug in another point to solve for the a value.